Have you ever wondered how the moon got its craters? What cosmic collisions and fiery impacts have left their mark on our celestial neighbour? Well, lunar craters are like the age-old scars of the moon, the result of billion-year-old cosmic collisions. Imagine asteroids and comets, these celestial nomads, hurtling through the vast expanse of space, drawn in by the moon's gravitational pull. Upon reaching the moon, they crash into its surface with an incredible force, releasing immense amounts of energy. It's a spectacle of cosmic proportions, a dance of destruction and creation that has been unfolding for billions of years. Now picture the aftermath of these colossal impacts. The surface of the moon shatters and melts, throwing up a cloud of dust and molten rock. This debris rains back down onto the lunar surface, piling up around the impact site to form the characteristic ring of a crater. It's a process as violent as it is transformative, forever altering the landscape of the moon. But these craters are more than just the remnants of celestial fireworks. They're a record of the moon's past, etched into its very surface. By studying these craters, scientists can piece together the history of lunar impacts, shedding light on the size, frequency, and composition of the objects that have struck the moon over time. And what a history it is! The moon's surface is a silent testament to the violent history of our solar system. Every crater, every scar tells a story of a cosmic collision, a fiery impact that has left its mark on our celestial neighbour. So, the next time you gaze up at the moon and its craters, remember, you're not just looking at the moon, you're looking at a billion-year-old cosmic battlefield, a record of the celestial collisions and fiery impacts that have shaped our solar system. These celestial collisions have not only shaped the moon's surface, but also offer us a window into the past, illuminating the violent history of our solar system. Not all lunar craters are created equal. Their formation, size, and structure tell different stories about the moon's geological past. Let's start with simple craters. They're the youngest of the bunch, with a depth-to-diameter ratio of 1 to 7. These craters are typically less than 9 miles in diameter, with a bowl-shaped depression and steep slopes. Simple craters are the remnants of high-velocity cosmic collisions. Their relatively small size a testament to the impact of smaller asteroids and comets. Next we have the complex craters. These are the middle-aged craters, larger than simple craters, typically stretching over 12 miles in diameter. Their structure is more intricate, featuring a central peak or a ring of peaks, along with terraced walls. These features are the result of a rebound effect following a powerful impact. The central peak is formed when the lunar surface, like a liquid, rebounds after the initial compression of an impact. Last but not least, we have impact basins. These are the elders of lunar craters, with diameters usually exceeding 300 miles. They are characterized by multiple rings and often host seas of solidified lava known as mare. These are the scars left by the most catastrophic collisions, bearing witness to the most intense periods of bombardment in the moon's history. The role of volcanic activity and tectonic processes in shaping these craters cannot be overlooked. Volcanic activity, for instance, has played a significant part in the formation of lunar maria within impact basins, while tectonic processes have contributed to the terracing seen in complex craters. In essence, each type of lunar crater, simple, complex, or impact basin, has its unique characteristics that reveal different aspects of the moon's geological history. They provide clues about the nature of the impacting bodies, the moon's volcanic and tectonic activities, and the processes that have occurred over billions of years. Each crater is a unique testament to the moon's dynamic geological history, a silent witness to the violent and transformative processes that have shaped its surface. The study of lunar craters isn't just about understanding the moon, it's about understanding the broader processes of cratering across the solar system and their implications for planetary evolution. You see, the moon is like a cosmic time capsule. Unlike Earth, the moon lacks tectonic plates and a robust atmosphere, which means the impacts that create craters remain visible for billions of years. These craters provide a record of the frequency and scale of impact events over a vast stretch of solar system history. And it's not just the moon. These processes are universal. From the furrowed plains of Mars to the icy moons of Jupiter and Saturn, the scars of celestial collisions tell a story of cosmic violence and renewal. The size, shape, and distribution of craters on different worlds can offer clues about their geological histories, the nature of their surfaces, and their past and present environments. For instance, Mercury, the smallest planet in our solar system, is heavily cratered, suggesting it has been geologically inactive for billions of years. Mars, on the other hand, displays a blend of ancient, heavily cratered terrains and younger, lightly cratered regions, hinting at a dynamic geological past. Cratering processes can also shed light on the early solar system, when planetesimals and leftover debris from planet formation were colliding at high speeds. By studying the craters on the Moon and other bodies, we get a glimpse into this turbulent era. Moreover, the analysis of lunar craters can help us understand the impact history of Earth. Given Earth's active geology, many ancient craters have been erased, but the Moon, our silent companion in space, has been keeping a record. So as we delve deeper into the mysteries of lunar craters, we're not just gazing at the Moon, we're peering into the history of our solar system, deciphering the tale of planetary evolution. The craters of the Moon are a microcosm of the larger cosmic drama of planetary formation and evolution, offering key insights into the history of our solar system. Lunar craters are more than just a window into the past. They are also a gateway to the future of planetary exploration. Our lunar neighbour has always been a stepping stone for space exploration. The craters that pockmark its surface serve as a constant reminder of the cosmic ballet that has been unfolding for billions of years. They are a testament to the dynamic processes that have shaped not only the Moon, but also other celestial bodies in our solar system. As we set our sights on returning to the Moon and even venturing further, these craters become increasingly important. They serve as a kind of roadmap, guiding us towards possible landing sites for future missions and hinting at where we might find valuable resources. In the depths of these craters, we may discover reserves of water ice, a precious commodity for long-duration space travel. This water could be used for life support or even converted into rocket fuel, making the Moon a potential pit stop on our journey deeper into space. But it's not just about where we're going, it's also about where we've been. The study of lunar craters provides us with an invaluable record of the solar system's history. Through careful examination of these astral scars, we can learn about the frequency and scale of past impacts, giving us a clearer picture of the cosmic environment in which our planet evolved. Recent discoveries and observational data are providing us with fresh insights. We're learning more about how these craters formed, how they've changed over time, and what they can tell us about the geological history of the Moon. Every new piece of information brings us one step closer to understanding the intricate dance of celestial bodies and the forces that shape them. In the grand scheme of the cosmos, our journey of exploration is just beginning. But with every crater we study, every mission we undertake, we're not just reaching for the stars. We're seeking to understand our place among them. As we continue to explore the Moon and beyond, the study of lunar craters will remain an essential tool in our quest to understand the cosmos. Despite centuries of observation and study, lunar craters continue to captivate and intrigue us. These celestial scars are far more than just surface markings. They are tangible evidence of the cosmic ballet that has been playing out for billions of years. Each crater tells a story, a tale of confrontation and transformation, a testament to the dynamic and violent nature of our universe. The enduring fascination with lunar craters is not just about their aesthetic appeal, it's about the scientific treasure trove they represent. These craters, with their varied shapes and sizes, provide invaluable clues about the Moon's past. They help us decipher its geological history, understand its evolution, and unravel the mysteries of its internal structure. But lunar craters are not just about the Moon. They serve as a window to the broader processes that govern our solar system. They tell us about the frequency of cosmic collisions, the nature of asteroid and comet impacts, the effects of volcanic activity and tectonic processes. They shed light on the birth, evolution, and death of celestial bodies. They help us understand the past, predict the future, and navigate the present. The significance of lunar crater research extends beyond pure scientific curiosity. It plays a crucial role in planetary exploration. It aids in the search for resources, the selection of potential landing sites, the planning of future lunar missions. It helps us prepare for the challenges and opportunities that lie ahead as we venture further into the cosmos. Recent discoveries and observational data have only deepened our fascination with lunar craters. They have offered new insights, raised new questions, sparked new debates. They have reminded us that the Moon, despite being our closest neighbor, still harbors many secrets, still holds many surprises. From their formation to their future, lunar craters continue to offer us a fascinating glimpse into the dynamic processes that shape not just the Moon, but our entire solar system.